Hi, everybody. Thanks for coming to my talk today. I'm Johann Wenzel. I'm a PhD student at the University of Waterloo, and I'm here presenting Understanding How People with Limited Mobility Use Multimodal Input, which is a project I completed as part of an internship with Microsoft. I finished this project with the help of my co-authors, Sasha Januzovich, James Devine, John Porter, and Martez Mott. So mostly as a commentary on my own attention span for presentations, I'm going to summarize our findings here. So first, we find that when people with limited mobility encounter accessibility barriers, one of the most common remedies is to combine input devices. Second, we find that these input combinations are strongly based on individual mobility needs, with a wide range of combinations to suit a wide range of people. These accessibility barriers are generally caused by mismatches between the user and the device, or between the device and the application. When people with limited mobility are looking for ways to combine devices, they often look to social media or word-of-mouth recommendations. Then finally, we make recommendations for increasing accessibility, specifically by adding tools to discover and configure input combinations. So I'm going to start things up with a quick primer on degrees of freedom and multimodality. Think about the different input scenarios that you encounter every day. You might browse the internet, mess around with 3D models, play a game, or even combinations of these at the same time. Each of these situations takes in user input at a different level of complexity, and as such, they demand input with increasing degrees of freedom. In this context, degrees of freedom refers to the domain of input provided by each different device. For example, a keyboard with 101 keys can provide 101 sources of binary switch input. The key is pressed or it's released. A mouse provides data for its X and Y motion on your desk, as well as click events and up and down scroll events, and any other buttons on a fancy gaming mouse. Likewise, a gamepad has a complex combination of buttons, triggers, binary or analog, and joysticks. Now, think about controlling an application like Unity. It's a complex program that involves input in 3 dimensions, mouse interaction, keyboard movement, often at the same time. The more complex your interaction is, the more degrees of freedom of input it expects. But what if users can't provide that input with the devices they have in the fidelity the application expects? For example, consider a user that has trouble holding and using a controller, but in their normal computer setup, they use a keyboard, a switch setup, and a mouse to provide that same level of input. For several games and applications, why not approximate or recreate that input using devices that users already have? This is what's called multimodal input, combining devices with multiple degrees of freedom into one cohesive form of input. So the overall motivation for this project is, how do people with accessibility needs utilize multimodality and multimodal input in their everyday computer usage? And how can designers use it to make more accessible interfaces? This has a few sub-questions which we investigate in the paper. Namely, which devices do people with limited mobility use and how are they combined? Next, how are these choices affected by context like application type, hardware, or other factors? And finally, how can developers and designers accommodate the wide variety of existing setups? We surveyed 43 people with mobility limitations to look at their preferred devices and input configurations. First, we asked respondents which categories of computing device they own. So this includes smartphones, desktop computers, laptop computers, things like that. Next, we asked them to list all the input devices they use with these computing devices. So this includes stuff like mouse, voice, keyboard, touchscreen. Note that in this categorization, we split out controller and voice because there are special categories of input that kind of don't really fall into the categories of discrete and continuous. So after the surveys, we decided to get a deeper insight into the context and the conditions that affect how people create these multimodal input configurations. So we found that most people preferred slower paced games as they were generally more accommodating for different styles of use. And as well, here are some notable quotes from the interviews. I'd rather find a game I can already play than try to buy special hardware for just one game. Sometimes finding a game that works is luck of the draw. There's often no preview and no way to know if I can change the controls. VR's lack of accessibility makes me feel disabled all over again. And I don't usually play in groups because they usually don't understand why I'm moving slow. The issues and remedies associated with combining input devices can be broken down into a two-step matching process between the user and the device, and then the device and the application. So in the mismatches between the user and the device, people often employed alternate usage styles, which include conventional usage with alternate control schemes, adapted grip, which is a different usage posture, so say changing how you hold or use the device, adapted device, which is a hardware modification, or alternate device, which is swapping the input device for another entirely. So say swapping an Xbox controller for a quad stick. And then remedying device application mismatches, people use two things: virtualization, which is emulating a more compatible device, so say using a software keyboard displayed on a screen, or remapping, which is changing input functionality entirely, so say tilting a joystick to the left to emulate left click. But one of the biggest things we found in the interviews was that people didn't create multi-device configurations out of nowhere. In most cases, they sought outside help from either people that they knew, recreational therapists, or most commonly, social media like YouTube or Reddit. As such, the third part of our investigation aimed to simulate that process of searching social media. We searched YouTube for all combinations of 60 accessibility-related keywords and 8 gaming-related keywords like Xbox, PlayStation, things like that. After establishing a dataset and narrowing it down using preset inclusion and exclusion criteria, we ended up with 74 videos from 66 unique YouTube channels. We categorized the videos based on usage style, platform, number of input devices, user position, and device position. And then finally, we used Cohen's kappa as a measure for inter-rater agreement in this analysis. I'm not going to list it all here, but our main findings are that most videos showed one device being used, but the vast majority of those one device videos showed users playing on a game console. Videos showing console gamers had a bigger variety in usage styles, but the videos showing PC gamers showed more alternate devices being used. Videos of console gamers showed them using multiple body parts more often. In terms of the lesson learned, the differences in device compatibility between console and PC games affect how users engage with these games, from body position to device choice. So there are 3 primary takeaways from this analysis. In terms of general support, designers need to design their apps to accommodate a wide variety of hardware and combinations, especially including options for remapping like you see here, which is the Steam layout screen. Next, discovery. Tools to help users discover and implement multi-device configurations will make a significant difference to a system's usability. And finally, many users reported using virtual devices like a software keyboard to supplement real ones. Researchers need to consider virtual devices as a meaningful part of future device spaces. So that brings us to the end of the presentation, and now I'd love to take any questions you might have. Otherwise, feel free to reach out via Twitter or email. Thank you.